Hey everybody, Mr. Longo is back for another outdoor video. So we're going to solve by completing the square today, but of course, we need to talk about what completing the square is. So if we have x squared plus 6x, in order to do what's known as completing the square, what you're going to do is you're going to take half of the b value and you square it, and that gives you 9. But by doing that, it means you can write this as x plus half of the b value again, which is 3 squared. Okay, so you're going to have x plus 3 squared, which if you were to multiply it out, x plus 3 times x plus 3, you would have x squared plus 3x plus 3x plus 9, which is x squared plus 6x plus 9. Now, you probably don't know why that's important yet, but once we start solving, you'll see why we want to do that. So this next example, you still have to take half no matter what it is. So in this case, we have 5. So half of 5 is 5 halves squared. We would have 25 fourths. And then to write it as a square, we would have x minus 5 halves squared. Okay? And even in the last one's even more complicated. Because before you can complete the square, you need to get rid of this leading coefficient. So the first thing you're going to do is divide that out. So you'll have 2, and then x squared plus 3 halves x plus whatever is going to go on the line. Now, we still have to take half of that. So half of 3 halves is 3 fourths. Squared, we're going to fill this with a 9 sixteenths. Okay, and then we would have this written as 2 times x plus 3 fourths squared. Okay, so again, if you are not a fan of fractions, I'm going to highly recommend that you go grab your graphing calculator, because your graphing calculator has no issues with fractions and can work with them just fine. So make sure you have that ready if you would like a little bit of assistance with fractions. Okay, so now that we have gone over how you complete a square, let's show you how you use it to solve an equation. So the first thing you would have to do is subtract your constant to the other side. So we would have x squared plus 8x, and that would be equal to a negative 12. Now, you know how to complete the square here, so what you would do is add and leave a little bit of space. Now, I want you to keep in mind we need to balance both sides. So this needs to be a balanced equation. So half of 8 is 4, squared is 16. You need to add the 16 to both sides. You can't just add 16 to one side, or then all of a sudden you're changing the entire equation. What I mean by that is if you were to have 2 is equal to 2, which we know is a true statement, if we were to add 16 to one side, you'd have 18, and it's no longer a true statement. But if you added the 16 to both sides, you would have 18 equals 18, which is still a true statement. So that's why you must always balance your equations. So now we know that this can be written as x plus 4 squared, and that would be equal to 4. And now this should ring a bell. This was one of the last videos you watched, is how to solve by square roots. So when you don't have an easy way of factoring, this will become very helpful. So from here, you would just square root both sides, just like we did in the last video, and we would be left with x plus 4 is equal to plus or minus 2. And this is where you had the options. You can split it if you want, and say that x plus 4 is equal to 2, and x plus 4 is equal to a negative 2, or you could have just continued by subtracting 4 from both sides once, and have x is equal to a negative 4 plus or minus 2, which would still give you negative 4 plus 2 is a negative 2, and negative 4 minus 2 is a negative 6. Okay, now that one, I'm just going to give you a little hint. We could have just factored that. We could have said x plus 2 and x plus 6 will multiply to 12 and add to 8, and then you would still get your negative 2 and a negative 6. But all quadratics are not always factorable. So that's why you need to have another way of solving a quadratic equation if it can't be factored. Just because a quadratic equation can't be factored doesn't mean there's no answers. It just means we can't do it quickly and easily. So for the next one, what we would do here is if we were to have this, it would be x squared plus 6x minus 3, which you cannot factor. So that's why completing the square is very helpful. So x squared plus 6x is equal to 3. You have to get the constants on the right-hand side first. And now what we're going to do is say half of 6 is 3, squared is 9. So we're going to add 9 to both sides. We can write this as a square of a binomial now. This would be x plus, because we're doing half of the b value, so that would be plus 3 squared, and that's equal to 12. Square root both sides, and you have x plus 3 is equal to plus or minus square root of 12, which you must simplify. So that's actually x plus 3 is equal to plus or minus 2 root 3 after you simplify the square root of 12. Subtract 3 from both sides, and your answer is x is equal to a negative 3 plus or minus 2 root 3. Okay, so that is one of the reasons why we need another way of solving a quadratic equation for when we can't factor. Okay, there is another way we can do it as well, which we'll talk about in a later video. So now that you've just seen it done, why don't you pause the video and try this guy over here, the one on the left, x squared plus 5x plus 4 equals 0. That way we can talk about that one before we get to a couple that are a little bit more intense. Okay, so pause the video and try another easy one. Okay, so this guy we're going to have x squared plus 5x is equal to a negative 4. Half of 5 is 5 halves. Squared is 25 fourths. Okay, remember, you must be able to work with fractions. If you can't, make sure you have your graphing calculator with you at all times. And you have to add that to both sides. To write this as the square of a binomial, we have x, this symbol plus, we're doing half of a positive 5, which would be a positive 5 halves. Squared is equal to, let's see, that sounds like a negative 16 fourths, so this would be equal to 9 fourths. Square root both sides, and that's going to end up giving you x plus 5 halves is equal to plus or minus the square root of 9 fourths is 3 halves. Subtract 5 halves from both sides, and you have x is equal to a negative 5 halves plus or minus 3 halves. So, negative 5 plus 3 would be a negative 2 halves. So one of our answers is x equals negative 1. And negative 5 minus 3 would be a negative 8 halves. So the other one would be negative 4. So sometimes it's actually a lot more work to be able to complete the square, and you also had to work with nasty fractions. So whenever something can be factored, what you would want to do is just factor it. And there you go. You would get negative 4 and negative 1 in 2 steps instead of all those nasty steps. But again, you have to remember the purpose of this video is to show you how to complete the square. So the next one. First thing you have to do is factor out your 2, leaving you with x squared plus 4x, and that of course is equal to the negative 3. Here's another tricky part. Remember, we need to stay balanced on both sides. So half of 4 is going to give you 2 squared is 4. But look at the left. We didn't add 4 to the left side. We actually added a 2 times the 4 if we were to distribute. So that would technically be 2x squared plus 8x plus 8. So we need to add 8 to the other side. Okay? And now that's going to give us 2 times our x. Half of positive 4 is positive 2. Squared is equal to 5. Divide both sides by 2, and you have x plus 2 squared is equal to 5 halves. And now is where another crazy thing comes into play. We have to square root both sides. And we have x plus 2 is equal to the square root of 5 halves. 2 things are happening here. Number 1, this is the square root of 5 over the square root of 2, and you can't take the square root of 2. So you have to rationalize your denominator. So this is actually x plus 2 is equal to plus or minus the square root of 10 over 2. Remember, no radicals in the denominator. If you forget how to divide by a radical, you need to go back and watch a video on simplifying radicals. Okay? Then you subtract 2 from both sides, and x is equal to a negative 2 plus or minus root 10 over 2. And again, that is why we need to be able to use completing the square, because you could not factor that. And if you can't factor it, then you need another way of solving. Okay? Last one of the day. This one's going to be pretty nasty. But I just want you to be able to, see it, be exposed to it. First thing you do, subtract 6 from both sides. So we have 3x squared plus 5x, and that's equal to a negative 6. Watch this next one. We have to factor out a 3, leaving us with x squared plus 5/3 x. And now we need to take half of 5/3, which would be 5/6, and square it. So 5/6 squared would be adding 25/36 to this side. But remember, before you multiply that to the other side, you have to multiply it by 3. So 25/36 times 3 would actually be 25/12. 25/12 sounds good. So that would be plus 25/12. Okay, and now you need to continue the fun. 3. This is an x plus half of 5/3 would be 5/6 squared is equal to negative 6 would be a negative 72/12, and negative 72/12 and 25 for some reason to me sounds like a negative 47/12. Okay, and then as you can see right now, we are going to have a whole bunch of nastiness coming our way, because now we have to divide both sides by 3. That's going to give us x plus 5/6 squared is equal to negative 47/36. Square root both sides, and you get x plus 5/6. That's equal to I root 47 over 6, because we cannot simplify the square root of 47. The square root of a negative number is I, but the square root of 36 is 6, so we didn't have to do anything fancy with that one. That was easily, we were easily able to take the square root of that. Finally, subtract 5/6 from both sides, and you're at x is equal to negative 5/6 plus or minus I root 47 all over 6. You can also write it as negative 5 plus or minus I root 47 all over 6, because they have the same denominator. And if that one seemed easy to you, oh my goodness, you are a rock star. But that was it. That last one is quite a difficult question. We will have plenty of time to talk about more like this or any easy ones in class, so make sure you are ready. So this is Longo, and I'm out. See you, bye.